Hi everyone, welcome to KubeCraft. Here today we'll be having a funful session and with some of the amazing speakers, Prithvi, Usman, and Ram. And today we'll be talking about platform engineering, how it has grown over the period of time, and what all we can do right now. So I would like to invite Usman for the first session. Hi, Usman.
Hey, hey, anime, hey, everyone.
So let me introduce. So Usman is a staff developer advocate at Grafana Labs. He is currently residing in Germany, and he works with an open source community on community forums such as GitHub, Slack, and very active still on meetups and LinkedIn. He has over 15 years of experience in IT and in cloud support, where he served multiple customers all over the Europe, US, and Japan. He's also a very active international public speaker, participating in multiple conferences and events. So I hope I made the justice to your introduction, Usman. Now over to you.
Perfect, thank you. Let me share my screen. Okay. Um, so can you guys see the screen?
Yes, it's visible.
Okay, perfect. So yeah, thank you very much for the great introduction. Really appreciate it. So yeah, the first session is about like a walkthrough through the open source ecosystem in the CNCF observability landscape. So this session is for everyone. You don't need either you are new to CNCF or the observability, or you are someone experienced. So it is for both. It is something good for everyone, I would say. So yeah, let's start. Um, so a little about me, yeah. My name is Usman. I work in Grafana Lab as a staff developer advocate, and basically I work, yes, with the open source communities. Either they are on community forum, GitHub, or Slack, and also as a DevRel, like do the stuff like creating content. I'm still very much in doing technical stuff, so I create technical demos and technical tutorials and videos. And in my previous role, I have been mostly playing with Linux a lot. So I back in the days, I was like started from a tech support for Linux, but then it grows into the cloud Linux support, and it was fun experience. And beside work, yeah, I live in Germany. I have a small family, so most of my time goes with fatherhood. But whenever I'm free, I really like to do creative stuff with Linux and open source tools. So that is why I start creating some tutorials, which is like both if beginners and advanced use cases. Start from beginners to advanced journey, and also I like to write stuff. So if you are interested to more know about me, so you can scan this QR code, or you can even just connect with me on LinkedIn. Both works fine. So yeah, let's get started for this today's session. So today you definitely here to learn about platform or for the CNCF stuff, and this is we're gonna take through. But first we will start a little bit about Grafana. So if you're new to Grafana, so Grafana is a known product in the observability landscape, and it's basically a tool used for visualization, as people know, which is correct. But we gonna take a deep look like what other things it can does, and it is available on all platforms. Either you are running Linux, Mac, Kubernetes, Docker, you name it, like it's available everywhere almost. And it supports various visualization formats such as the famous time series or bar charts and so on. And the cool thing is that basically you don't need to like configure in a traditional way that you have to configure in databases or so. You only need to tell the Grafana that this is my endpoint or the source of data, and use particular sources or plugins, we say, and connect with it, and it will start showing you the data in a dashboard panel and so on. So you probably see some of these icons somewhere. So yeah, you know Grafana, you may know Grafana Labs, and they have some different product. They also have Grafana Cloud as well. But the other things you may know, at least know, is like Grafana Loki and Grafana Tempo. But what has changed? So basically, you know all this stuff, but um, what is new? So a lot has changed in the recent, basically. So we have a new back end and front end. So uh, I would say the front end is more newer. The back end is still the same. So the back end is written in Go language, but the front end is TypeScript. Before that, in the earlier versions, it used to be Angular, but with that change, basically we want to bring some stability and features that are more support use cases and works better as a full application. Uh, we also now working a lot in the AI ML part, so large language models. We are trying to create some integrated tools in Grafana, and that actually is maturing with time. It's already there, but it's still obviously it needs some more training to get more and more better, but it's on public use. And we had recently launched Grafana 12 as our major release. So that contains a lot of new features, which we gonna take a look a little bit as well. Yeah. Now, in my previous slide, I showed you some of the names like you may have heard of Grafana Loki, Grafana Tempo, and so on. But here is the full product stack diagram, which can help you to recognize like what actually Grafana can do for you, either you're a platform engineer or someone who's just doing some engineering or maintenance work or SRE, you name it. So at the very top, we basically see that, hey, this is our visualization UI. You probably see this screen if you're a Grafana user almost time to time. And then we have data sources. We call it like Big 10 data sources, but they are basically data sources of various categories. So let's focus on like the fun, which are, let's say, very common or in the open source realm. So such as uh, um, some names are like Salesforce, Oracle, MySQL is could be also there. Yeah, it doesn't matter what it's in the image, but it's just a representation with icons like what could be your data sources. So GitHub, or even some maybe of you are using like New Relic or Dynatrace, which is fine. So you have your data sources. And basically, you connect your data sources or running your data sources in an environment. And if you need those metrics from your sources, where you are running it either in a particular infrastructure environment, and so you can get this whole complete observability using the Grafana stack. So at the very bottom, you can see it says Loki, Grafana, Tempo, Mimir, and Periscope. So Loki is for the logs, basically all the log files you can use to visualize, and for analytics, you can use Loki tool. Grafana is definitely for the front end visualization. If you want tracing, that you want your data as how it goes with the flow, if you make a request and how much time it's taking, you can use Tempo for tracing. And for metrics, you can use Mimir. You can use also Prometheus, and there is also Mimir. There's a very slight difference of the data retention, but Mimir is also our product. And then there is something not new, but it's still like when I say to people, I say like, hey, it's still new. It is called profiling, and the tool name is Periscope. So if you want to see the graphical data, like how much time when you make an application call, why it is taking so much time, or where is the block of the code which is consuming too much of your memory or your time, you can use profiling tools such as Periscope. Now, the cool thing is that like this whole stack is open source. You don't need to pay for it. You get all the features for free. So this is something maybe not so much people know about it. And yeah, you can use in different areas for cost management, security, configuration. And we still have some more tools for performance testing. We have K6 for load testing and browser testing. For application observability, we have front end, Faro, eBPF, and so on. For infrastructure observability, we have Kubernetes app integration available. Obviously, also for your databases and cloud providers. And last but not least is the for whole alerting mechanism. So this is the complete product stack when you see Grafana as a whole. It's just not the front end visualization tool. It is a complete stack for your whole metrics, logs, traces, profiling, and even testing. And this works for your any public or private platform or cloud provider, whatever you are using. So we start a little bit about the visualization. So Grafana support default visualizations such as time series and bar chart and so on. We will take a look into it. And yeah, and we also have introduced Canvas plugin, which is very new. Basically, it's a very unique way or customized way to show your data representation, like how you want to, for example, how the flow of a circuitry or electrical component is going and how much in real time the data is processing. You can customize it from traditional graphs to more like in a digital way or in a fun way using some canvases. And we also provide custom options because the thing is that like many of the tools, like they have limited availability, but in Grafana you can do this custom option if you want to change the unit or change even the currency of your expenses. You can do it and apply some other custom options as well. Logs, which is the tool we have known as Loki to visualizing or analyzing your log files. And Loki is again, yeah, it is open source. And here is just an example how the Loki works. So at the very top, you can see this line which says like, hey, there's a timestamp and there's the details about my app, which is, let's say, Nginx, and the environment could be dev or prod, whatever. And then you have this log line which contains the information like what happened at that particular timestamp. So you have basically timestamp, labels, which are basically key value pairs, and then the content. So normally, many of these traditional tools, what they do is that they index the whole log line. So they get the index everything. And what turned out to be that you probably, I mean, disk space and memory is cheap, but you still run out of disk space and or the application takes too much time to do this operation. What Loki does is that it only indexes this part, this content line. Um, sorry, my bad. This only indexes the timestamp and the key value pairs. And with that, what happens is that your original 10 TB of log file becomes only 50 MB after indexing. So basically, you save a lot of disk space by indexing this. So you, instead of 10 TB, you maybe have only 3 TB after compressing the logs. So this is big thing because logs are needed everywhere, and regardless how what kind of platform you are running, you need to check the logs, and those are very essentials. Like even before metrics, you first thing you see like, hey, I want to check the application logs for my platform, and Loki is definitely something you can use very proficiently in your environment. Continuous profiling, it is known as Pyroscope. Basically, it tells you like how much usage of your code is done in more detail. So, for example, imagine a case that you are running a custom application for your custom application for your customer, and you define this custom plugin for that. What happens that after the next release, the same code is taking too much time, like to take a to get loaded into the environment or into the front end, and you can use Pyroscope to analyze like which code block is taking time and so on. So uh, and profiling is definitely important because it covers the missing yeah, it resolves the missing puzzle for your data or observability, that okay, you have logs, metrics, and traces, which are the three pillars of observability. But with profiling, you can identify in more detail what is the exact root cause, how that root cause occurred, and how you can then later fix it. So let's take a very quick demo. So basically, here is the um, for visualization, like you can check, like for example, canvas panel. So this is the canvas panel. You can see this is a real-time event. You can start, standby. This is just a demo, but you can obviously integrate it. And this is how you can create the canvas panel. You can put, if you have like data which is real time, you can modify it, define it like this is my data source, and take a look into it. And this can then become real time. This is currently obviously a fake data, which is not refreshing every time. But if you have a real data, all these information like the information about what and so on can be changed on real time. And this looks very interactive and more detailed than the traditional time series panel, where maybe you understand everything, but not the others may have full understanding how it works. Similarly, for the logs, we have the Loki dashboard. So this is a very good dashboard to represent your log files. Using Grafana Loki, you can see the whole HTTP status for 200 errors, for 300 plus, and so on. And you can even view the recent request, obviously then do the fancy work with the um, uh, time series visualization panel, to create panels for time series and see the status in more detail. But this is a very good and clean look of a log panel dashboard. So you can identify any points, thresholds in your logs which you need to check in day-to-day operation. Okay, moving on. Now, I always put this question. This is for me a fun question, because whenever I talk in events or to the users, or even someone, even in the community, the first question comes like, hey, I'm using Grafana with Prometheus, when it comes to the understanding like how Grafana works. So does it only work with Prometheus? Let's find out. So actually, it works almost with everything. So you can use Grafana with the tools in your platform environment, whatever you need to. You can use Grafana with them so that you can get all the key metrics, data, and even visualize log files or tracing, you name it, in a single unified solution. So you can see some of the names here, which are definitely you probably might be using. And even some of these names you see like, hey, these are some of the open source tools, and I can easily identify at least 2 to 3 CNCF tools as well. So, and I'm not going in detail in this picture now because we will come back to it for it later. So um, we just understand that, okay, this is Grafana does not always need or only need Prometheus. It works with other tools. So those other tools, how they work. So we have something called like Grafana plugins. So plugins basically connect and view the data. So you install a plugin, and then once it is configured, you can view the data in Grafana. It is mostly built inside the core, so you don't need to do anything, any like write from scratch to just use it or so. Obviously, if you want to create your custom stuff, then you have to build in, which we have some guides as well. But by default, the most popular ones are available from the core. And yes, there is community and enterprise as well. So I put the word enterprise here because this is important, that obviously we are talking here about open source, but there are some requirements for your customer, that you need to use some enterprise stuff in your platform. It's not about just like using enterprise software. It might be like some enterprise create level tools that it is that is mandatory to get the data. So and for the support part. and and also we have a big amount of contribution from our community. So if they have wrote some amazing Grafana plugins, so you can use them. And this is the breakdown. So plugins can be defined in data sources, panels, and apps. And then there's a like data sources we know like plugin data source. So that's just an example. Okay, now we move to the bigger part, which is the more fun part. So let's talk about the CNCF landscape. So this is the CNCF landscape looks like. don't get scared with the dragons and the hounds or bulls, I would say. Yeah, so it's pretty big. There's no doubt about it. It's very vast and it's also very complicated as well. So there are tools specific for containerization, for orchestration, application, service mesh, proxies, etc., CI/CD tools, and then there is also a big category for observability and analysis tools. So you're probably using some of these, or maybe a combination of these in your environment, which is good. You should use open source as your preferred solution, especially the CNCF ones. And how CNCF and Grafana are working together and helping each other. So both are open source first. Our priority is to first help the open source user and be more community specific. Grafana is a very heavy contributor to the CNCF tools such as Prometheus and also some or like Kubernetes and OTel. I think recently Grafana is the top 5 most contributor for the open telemetry. uh, yeah, I think I'm pretty much right there. If wrong, apologies. But yeah, and also Grafana is also a contributor on other tools like some open source tools such as Docker and so on. We wrote some applications for created some Docker-based application with the integration of Grafana. So that actually helps the community who are using Docker instead of some other tools. Again, it depends on the use cases. And finally, the most important for me is like both are community driven. So a lot of feedback, help, and support come from the community. But there are challenges. So challenges is like when you run Kubernetes, because yeah, it is important that you need a tool which can scale up, scale down, and can support your complex application. Then the Kubernetes is definitely the solution. And what you expect, so you expect like, hey, when I am running Kubernetes, I want complete observability, like how many pods, services are running. Even you have like tons of namespaces and deployments, you want complete information and understanding like how the services are running. And you also want to avoid integration overheads because you want to keep it as clean as possible. That's again the ideal case. But what actually happens, so you want to identify the right tools in or platforms so that it doesn't go like haywire. You also want to keep the cost as minimum as possible, because the thing is that like Kubernetes is really powerful, but you scale up too much, then the cost will also go too much for your team. And definitely, the last but not least is you want to keep it up to date with and not use like outdated technologies or tool. This is important because we are living in a tech space which is like rapidly growing, and if you stuck with legacy software, then or tools which are outdated, then it is very hard to come off it. So you want to keep them up to date as possible. So with all of this, let's get to the conclusion slowly. So you understand, and you might be thinking like, hey, yes, that makes sense. Like use reliable tools, or I'm more interested to learn about like tools which are reliable. What's it in for me? Why are you hearing this presentation, which I'm talking? I have already talked about CNCF tools. I have talked about Grafana, or you're just again a new user. You are very understanding, okay, the concept of all these terminologies, or more important, how can I help, like where you can be useful. So this is where you can be good and you can bring reliability or help and build a strong relationship is through the community. And I'm not just talking about the CNCF community, I'm also talking about the communities which are from Grafana Labs as well. We are 100% open source. We prefer the open source solution first, and this is where you can help us. So with through the community. So we also have like a three pillars, strong pillars of our community, like three pillars of observability. So the first one is definitely the GitHub. We are very much active on GitHub. We understand the problems and the use cases. Then the other two resources are the Slack and the community forum. The community forum is definitely something I prefer. Slack is also nice, so you can check that out. And I want to give a small demo, but I will hold on it because I want to come to other slide and then show this demo. So Grafana layer is the heart of community. We understand it and how this community is helping. So first take a look about, or we talk about the community dashboards. So again, you are using different different tools. So I think I wanted to show this picture now. Just give me a moment. Yeah, so you are in the CNCF landscape and you probably say like, hey, I'm using like Ham, I'm using other stuff like Argo CD. Argo CD is definitely very much famous. Also Flux. Again, nothing comparison, like it depends on your use case, Kubernetes and so on. And if you're using these tools, you obviously want to get the metrics and want visualization of like how the things are working and so on. So this is where the community comes first, and the first thing is the community dashboard. So this is from the community, by the community, and it supports many CNCF projects as well, we just saw, and time saving. And now let's take a look in the demo. So at Grafana, we have a collection of dashboards, basically, which are from the community. So for example, just give me a moment, I have to hook up my laptop. Yeah. Okay, so if you are using Argo CD, you can get all the Argo CD dashboard pre-configured. You don't need to invest time and create from scratch. Obviously, once you import it, you can modify it, but there is all things available. If you're using like, hey, I'm just interested in Kubernetes dashboards, so um, yeah, so you can use Kubernetes or K8's dashboard. You can get complete visualization in just a simple import in your Grafana. And it gives the details like what kind of data source you need. You need Prometheus, and then you start getting all these metrics in a single place. So this is where the community can help, or you can help through, like, the first step is the dashboards. So moving on, then the community plugins. So community plugins, we just talk about that. For me, what I say is that it is just like for like Prometheus exporters. Like we see different, we use different Prometheus exporters to get the data from the machine, and it actually brings like integration, innovation, interoperability. And this is actually extends the CNCF landscape. So what does it mean? That you're using dashboards, but you also want to create some custom plugins because you're using these specific tools. You can easily use this as they are available publicly in the Grafana plugins directory. So how you can find these plugins? So basically go to grafana.com, and instead of dashboard, just write plugins. And then you have a complete catalog of plugins. So if you go like data sources, you can get all these plugins. So you can see some of these plugins which you're like, hey, I know these names, or I can identify these icons. That is cool. We have plugins for or additional plugins for Prometheus. Prometheus by default is available in Grafana, but if you want like an alert management solution for your Prometheus as to visualize it, to get full observability, you can use these plugins as well. And I think just there's one, might be one more. Yeah, the Play platform. So the Play platform is basically, we actually saw earlier, like when we were viewing the Loki dashboards and the Canvas plugin. So it is also publicly available, and it is actually a good way to start to view like how you can shape your dashboards in an identical way or something similar. And this platform is it's more like learning by doing, or even by viewing, I would say. And you can share and export those dashboards. So what does it mean? So these are our Play platforms. So again, I go at home, and you can see. And if you're interested, like, hey, I'm very much interested to use maybe um, Postgres overview of these. So you can see all this Postgres data. You can say like, hey, I'm interested in this, creating this table. So you can get this idea like, or how you created it. So just click on like edit. You can actually edit it, and you can get, for example, the query and understand like, hey, this is how the data is generating. This is the pie chart I want to use also. So yeah, this is actually just learning by viewing. So this is pretty cool. And yeah, I think I was quick on demo, so we already saw it. Perfect. So, so last part is how to become the part of this open source ecosystem and help these both Grafana and CNCF. So the one way is definitely join our community, contribute to the documentation. We have documentation for Kubernetes. So if you feel like, hey, something has changed or something can be more improved, we welcome that. We have developer portals. If you want to write, interested, like, hey, I'm using this application and I really want to have like a customized plugin, which is very easy to build. But if you need the guidance, we have developer portals for that, and you can create your custom plugin or a community plugin, which is pretty amazing. And yeah, now I bring this picture back. So after you understand all of this, you say like, hey, now it makes sense. This picture, I do understand that there is actually an endless possibilities that could use with Grafana to visualize all my data or even logs or metrics, you name it. So I think this is amazing. So now the question is like, if you are new, you will probably like to contribute, but if you are already contributing, then what is the right track? So I would highly recommend that you can join the Grafana Champions program. It is for experts, but it is very good way to collab with developers. Maybe with me someday. I'm also there in that channel and get updated news. And so out of many, I will share only one success stories, which I think is the most great one or the most natural one for me. So meet Grant Pinkles. He lives somewhere in the States, and he started with Grafana community as a beginner. He slowly getting understanding of Grafana. Then he started become an active contributor on the community forum. He was very passionate. He wrote a tutorial and become then exclusive part of this Slack channel of the champions. And now he's more into like doing meetups, training other new users like how to be more active, more perceptive, how to do the talks and so on. So he's like making he's make his path, but he's not helping others to making their path as well, guiding them, nourishing them. And this is amazing. This is something very organic, very natural, and this is what we want for best of those both worlds. Like it is there's something for you, but there's something also for the open source realm as well. And this is my final slide probably. So the key takeaways is that select your own path of interest. So if you are a power user of Kubernetes, maybe use it. If you're a power user of just say like, hey, I'm not that much into Kubernetes, but I know some of these CNCF tools because I have to work with them day to day. Pick one, then polish your skills and expertise. Start working on it, playing on it, and maybe you are interested to learn more or do more. You say like, hey, why not contribute to the OSS because I now know this product pretty well. Maybe I can create a custom plugin or create a dashboard or maybe help users who are falling in the same problems as victims, which takes a lot of time. I can spread my knowledge and maybe create a video or tutorial, whatever. Or best is like write a blog post, because if you write a blog post, we can actually help you to publish it on our website. And this is also something very useful again, for you, for us, or for the open source community. So these are my kind of final takeaways. And yeah, thank you for participating. You can either contact me via LinkedIn, or if you have or email. I think LinkedIn is also, like, nowadays everyone is using it. So yeah, and you can also, like in the very beginning of the slide, there was a QR code. You can scan that and you can connect with other platforms which I'm using. So yeah, thank you. And I will be happy to take any questions.
So we have a couple of questions. I'll present them on screen. So one is by Sachin. How compression of the logs take place?
So basically, y- in Loki, Loki is the main server, let's say, and then Loki needs an agent. So the agent can be any of your choice. So Grafana is not. So Grafana has its own agent, which is known as Promptail, and now we have Alloy. But if you want to use your own agent, you can use it. And agent actually send this log information to the Loki, the server. And in Loki, there is a configuration file which is defined to uh, uh, by you or by default, and there is the parameters for the compression is set up. So um, they have changed something in very recent. I will be very honest, because Loki is also going in a very heavy improvement or in development phase. So this is where the compression take place. If you want to check more, I will really recommend to read Loki documentation, because then there is a whole lot of detail which is I cannot explain right now, but that will be the starting point.
Makes sense. I think I will drop the Loki documentation URL into the chat. Just dropped it there. Next question that we have is, can we make our own custom plugins? I think if you have any resources, you can
Yeah,
share it with us and we'll share it with the everyone in the group.
yeah. So basically, we have this guide, and as our DevRel team, we are working to make it more interactive. So this is the link. I will just share this on StreamYard. So uh, you can read this documentation, which can help you to create your custom plugin. And there's now like a video, so like if someone is a more visual learner, you can check it out. But this is really improved in recent, and you can definitely make your plugin more easily. It has the complete guide, complete step, and with that video, you can understand this a lot better. So yeah, definitely doable.
Awesome. I hope that answers Ayush. Next, we have, is it possible to monitor high cardinality metrics using Grafana while someone is working with Prometheus?
Um, Good question. I may not be the very right person to answer that. It could be possible, but uh, yeah, I will avoid to say how exactly how. I do not know. Um, eh, I will say
No.
check the Prometheus documentation. But if you have this question, I think this is a good question to ask in the Grafana community. I just want to share one quick thing. I think this is also very useful for the users. If you have a specific question like Prometheus and you want to know like how to do this high cardinality, definitely there might be a way to do it. Once you like join the Grafana community, go directly in the Prometheus one. Don't like shoot the question in like a random category. And this is where we have our developers, engineers, and ever some expert users can help you to answer these questions. So yeah.
Makes sense. I think that would be the right place to have this open discussion regarding cardinality metrics. The last we have is an appreciation. Grafana makes cloud native look beautiful by Ram.
Sorry, can you repeat the question?
It's not a question, it's like an appreciation that Grafana makes cloud native look beautiful.
Oh yeah, I was really, yeah, thank you, and I was also surprised. Like, there is a lot of usage of Grafana in the cloud native realm, and I think Grafana is definitely something which is like a becoming a de facto. Like when it comes like, hey, I would just want to use metrics. So yeah, and again, I will say like check out the Grafana 12 version. It has a lot of new cool features, so you will love it more.
I think those are the questions that we had. Let's Thank you, Sman. Thank you for. I know it's very early for you, and it was a very insightful session. There
Okay.
was a lot to learn, and there was a lot more news to hear about. Especially, I think the Champions program is something which will be very helpful for the people who are starting to contribute to the OS, especially towards the cloud native folks.
Yeah. Thank you again for giving this opportunity, and I hope that it was helpful. So yeah.
Awesome. So let's now move on to our second session, second speaker of the day. I would like to call Prithvi to the stage. Hi, Prithvi.
Hey
How are you?
Animesh, hey everyone for who's joining the CNCG Noida group. I'm doing good. How about you, Animesh? How are you doing?
Doing great. We have some high enthusiast. So it's very amazing to see them asking different questions and trying to build something of their own from the session. So quite excited.
Absolutely,
So
absolutely.
I guess we can move. Let me introduce you everyone to the Prithvi. So Prithvi Raj is working as community manager and developer advocate at Mirantis. And he is the leading effort for OSPO at Mirantis, including the KOS project, KOS Morton, and other OSS projects. Mirantis is also contributing to, and he has previously led the Litmus Chaos project community and has helped scale a community more than 3,000 folks from scratch. He is also a CNCF ambassador and has worked closely to co-organize KCD Bangalore, Chaos Carnival, Litmus Chaos Con, and previously he used to work at Harness. So over to you, Prithvi, and let's get this started.
Thank you so much, Mesh. Let me know if my screen is visible.
Yes, it's visible.
All right. So let's get started, folks. So we'll be talking about platform engineering, managing Kubernetes at scale, what platforms are bringing in, a little bit about new open source tool, Cordant. But yeah, mostly we'll talk about platform engineering and then we'll spend some time with Cordant. I believe Animesh has already given a brief introduction about me. So don't want to spend a lot of time about my introduction. My name is Prithvi Raj. My journey started with Litmus Chaos and Chaos Engineering as an open source community manager 5 years ago. I'm also a CNCF ambassador. I spent the last almost 4.5 years of my career building the chaos engineering and the Litmus Chaos community. We did some events in Litmus Chaos Con, Chaos Carnival, but right now I joined Mirantis. I'm supporting their open source program office and I'm helping run the K0S, Cordant, and Open SDN communities. And other than that, I'm also running a platform engineering and resilience engineering meetup group around Bangalore, and I help support the cloud native Kolkata chapter as well. So, what's on the agenda? I guess we'll find out. We all will find out. I'll be talking a lot about platform and engineering as I spoke about. So, I don't like putting out the agenda because I feel that there are a lot of points that are minute that might be important, or that are a lot of points that are not so minute, but like I believe they are large points, but the community finds them like it's all right, man. We know that already. So let's talk about what's in the agenda by starting off with something that we all know or we all thought would be simpler. When cloud emerged, say around 20 years ago, the promise was pretty simple. Just consume infrastructure as a service. The data centers are going to interact with the cloud infrastructure and everything will be easy. But fast forward to today, the reality has been quite different. I mean, there is a battle between multiple public cloud solutions, private cloud solutions, data centers, proprietary vendor stacks. There's a myriad of niche providers with their own APIs, infrastructures that have created a level of complexity where which large enterprises, large organizations are struggling to navigate. And if you see how the overall infrastructures look like, there are multiple clouds, multiple data centers, and a huge chunk of APIs interacting between them. And this is where we are in today's reality. I mean, and then we created containers, trying to, simplify all of this. We wanted to create container orchestrators, trying to make things simplify. And that is where initially there was Docker Swarm, and then there was Apache Mesos, and then Kubernetes was seen as the orchestrator of the future, where Kubernetes hoped or tried to make things simpler. But Kubernetes has matured itself, and now each and every cloud provider has its own Kubernetes provider. I mean, Kubernetes in itself is the underlying layer to each infrastructure, and it is providing an open source, open standard structure to simplify how you can use your cloud infras, how you can build your infrastructures to run your different workloads and satisfy the technical and business requirements of today's use cases. So even if there are the same amount of APIs, maybe today it's Kubernetes as an orchestrator that is basically on each and every cloud provider, but it is still complex. I mean, you have to use different services to manage these different Kubernetes clusters based on different clouds. Kubernetes is hoped to be seen as a common control plane. And make no mistake, I believe Kubernetes is a very powerful scheduler. But you need to ensure that Kubernetes functions in the right way, or you are able to utilize Kubernetes as the common control plane for all the clouds of the future. I mean, my hypothesis is you need to use Kubernetes as a thin layer to let use all your clouds, all your services, infrastructures to basically make Kubernetes the platform equipped with all your services. So Kubernetes, I believe Kubernetes has to be the interface to your cloud services, cloud environments. And although we have somewhat reached there with the concept of platform engineering, there's still a way to go, I believe. I mean, yes, we've been talking about platform engineering for long. We've been talking about building your own platforms, not focused on developers, not just focusing on developers as the main, front-facing folks. But I believe the way forward is Kubernetes, as I said. And let's talk about platform engineering. I mean, we are focusing on building internal platforms, streamlining your CI/CD pipelines, standardizing workflows, enabling DevOps, SREs, practices. But what exactly is platform engineering, and what brought this concept in itself? And let me be honest. I believe a lot of folks who are attending this talk or who might possibly watch this talk in the future are developers. And as a developer, you know what kind of a burden does a developer face in today's ecosystem, today's world. I mean, developers are not just asked to write their code, and I mean, developers were already burdened with writing their code and then testing them. They have to run different kinds of tests. There's no QA in the team. The SREs are missing. So the pen test, integration tests, everything is written by the developers. And post that, developers are also asked to learn new platforms. I mean, imagine that. Like, the developer onboarding and learning process has completely taken a fall. I mean, I'm not talking about organizations that are implementing platform engineering or have DevOps engineers. I'm talking about organizations that, in spite of having DevOps engineers or just having developers, are practicing forms of like asking developers to learn everything. Developers have to learn CI/CD. Developers have to learn chaos engineering, incident management, resilience testing, observability, logging, matrices. Developers are burdened with learning new tools. And after DevOps, the idea of DevOps was to separate the dev side of things and the ops side of things, where the delivery team will be different. And after DevOps, developers had to learn a few things, but then the ops side came in with the CI/CD side of things, monitoring tools, trying to enhance developer productivity. But what went wrong was that, in spite of DevOps teams coming in, there were multiple DevOps teams for multiple teams. There was no standardized approach. And even if after DevOps, software delivery sped up and became interesting, and developer experience, instead of suffering, was improved, all the cognitive overload and all the different DevOps teams where different teams had to interact with each other, it led to the eventual developer burnout. And let's be honest, developers just want to focus on writing code. And that is where platform engineering emerged as a way to remove this operational complexity while keeping all the benefits of DevOps. So I don't feel that DevOps is going null and void or DevOps is diminishing. I think DevOps will go on and platform engineering will stay around as a different aspect. But in my view, platform engineering is the discipline, it's the idea, it's the concept of building, maintaining internal developer platforms, which you can call as, basically a self-serviced experience to, ensure that your infrastructure complexity, your developers are empowered using a platform that has a standardized approach. So let us think of uh, an IDP as a developer's cockpit. Like a developer is served with pre-configured software, pre-configured infrastructure, where each and every aspect of software delivery. I was previously working a company called Harness. I spoke about it initially, and that was focusing on software delivery. So each and every aspect of software delivery, say from building your platforms with your CI/CD to your resilience engineering, security testing orchestration, your cloud cost management, all of it comes together to build the overall software that all your teams are using. And it isn't just about integrating tools, it is about crafting an experience where infrastructures become a product that developers enjoy using. So what we are trying to do is ensure that platform is portrayed as a product for the community, and that's the way forward. I mean, you talk about Terraform, you talk about Pulumi, you talk about all the tools that are out there, or even if you talk about the goals that Backstage have, you talk about the latest tool in Kratix. There are so many tools out there which are trying to ensure that platform is positioned as a product for all development teams. And that's why one of the major reasons to consider platform engineering is obviously production releases are happening every month. You want to accelerate your cloud native journey, and that is where you need to be agile. Costs are growing. I mean, you imagine an outage happening, and if your platform is not in place, or you are not having reliable tools in place in your platform to ensure that you can basically cover the outage. You can maybe run an incident manager or response orchestrator. The tasks become repetitive, and outages can cost not just financially, but reputational damage, loss of employer confidence. And today, with different teams acting, there are underutilized resources. You are wasting a lot of money, and things are not coming into place, and costs are growing. If you talk about teams or companies who are not implementing platform engineering today, take a look at their cloud costs, take a look at their other infrastructure and costs around different tools. I mean, purchasing licenses of each and every tool becomes a hassleful solution. And then obviously too many critical incidents are happening, application downtime, I think I spoke about it. And you have to be consistent in nature. It's too hard to manage different pipelines for each product, as I spoke about. There has to be a standardized approach which is secure and compliant. And that is where, what are the requirements for platform engineering? Today, teams need developer self-service. You need to accelerate your app development with the ideation of self-servicing and provisioning your resources. Your operational simplicity is important. You need to streamline your complex deployments across different clusters, across different locations, because teams are located, like some team is located in Europe. There are some other compliances there. Teams are located in Asia or North America. You need to ensure that your RBAC controls are in place. You need to ensure that your operationals are simplistic in nature. Your air-gapped environments are robust. And again, security and compliance. I mean, you need to ensure your safety and compliance and data consistency across clusters and applications. Lastly, you obviously need to put your monitoring, logging matrices in place, and you need to continuously be able to monitor these performance. And obviously, as IDPs have to be use case specific, tailored for each application team. Every application team has a different motto idea, so you need to ensure that you are able to, easily customize these platforms. And that is where platform engineering meets multi-cluster configurations. While creating IDPs, platform engineers need to be able to manage different clusters and different use cases. I mean, there are AI ML use cases. A lot of folks are moving to host Kubernetes on their GPUs. They have to manage your AI ML pipelines, AI workloads. There are hybrid multi-cloud environments. Some of the enterprises deploy workloads on, say, certain public cloud environments, on-prem, and need a holistic way to manage all of this. And then data sovereignty, obviously, there are country and state specific rules. In Europe, you are seeing an implementation of DORA metrics. There are different countries following different rules in itself for their, AI ML workloads or overall infrastructures. Isolation is important. You have to be multi-tenant and multiple teams projects. There, resource sharing is important, and they have to be highly available. I mean, fault tolerance, again, it's a very important core aspect. While I was involved with the Litmus Chaos community, we spoke a lot about chaos engineering, incident management. So, you have to ensure that you're able to run workloads across different clusters, and they are robust in nature, and they are well tested, and they don't have possible outages while your platform is in place. So I believe this is where platform engineering became powerful, became important, and why platform engineering is a core concept today. I hope I am able to explain a lot of it. And platforms have evolved over times. They need to be democratic. I mean, from being a rigid separation of development and operations to the emergence of DevOps to centralized platform teams. While platform teams aim to streamline developer workflows, there was often a bottleneck where with the demand scaling, there was a problem in terms of how you can streamline these developer workflows or ensure that these platforms are democratic. And that is where I believe that uh, I can conclude, or I can talk in a sense that platform democracy has to be a model where all your stakeholders, say your SREs, your security teams, your external providers, all of them need to be in place where they are producing and consuming platform capabilities by working as a central ownership group. And they have to ensure that I mean, your platforms are in the right place. Your platforms, sorry about that, just going back to the previous slide, your platforms participate equally. There's shift from the model of centralized ownership to a distributed collaboration, which is the central ownership. So you need to redefine your roles. Producers are no longer just the platform team, they include all the teams, your service providers, compliance engineers, internal teams, and obviously consumers expect that platform has to be safe, fast, and efficient in nature. And with this, we'll move on to how infrastructures as code have been essential in driving platforms. I mean, infrastructures as code have played an essential role in driving platform engineering. I believe everyone knows what is infrastructure as code, so I don't want to explain that. But the core role of infrastructure as code in platform engineering has been enabling platform standardization. Platforms, the IDPs are complex in nature. You need to make it simpler, composable modules which are reusable. So infrastructure as code has helped that. You need to drive automation and consistency. You want your environments to be replicated and reused and work on any machine without any errors. So you have to be consistent in nature, and rollbacks and disaster recovery becomes predictable if you are implementing infrastructure as a code to drive your platforms. It is one of the foundational layers, of course, to drive your self-service developer portals. You talk about portals like Backstage, Port. I mean, there are different use cases where your self-servicing developer portals are, triggered using an infrastructure as a code, and obviously you're able to support your GitOps and DevSecOps practices. It's easily integrated with various infrastructures, with Git as a single source of truth. Obviously, your infrastructure as code becomes the backbone of platform engineering, because it is helping you automate things, it is supporting your GitOps goals, it helps platform teams treat infrastructures as software, and obviously it accelerates the developer productivity. So with this, I would like to conclude what we have spoken about platform engineering. The idea is to ensure that Kubernetes is the orchestration layer. It is driving all your in modern infrastructures, your storage, your operating systems, your networking. And as platform engineering evolves, Kubernetes has to provide the consistent nature of empowering these IDPs and enabling them to be secure, resilient, and compliant in nature. So with this, I think we will move towards a concept that we spoke about, that is multi-cluster platform engineering. And that's the idea of multi-cluster platform engineering, and what are the challenges, because clusters are on different clouds, they are on different services hosted, I mean, in different infrastructures, and usually it was seen as a single application per cluster to be a best practice. Most enterprises are obviously adopting a hybrid multi-cloud strategy and are deploying across multiple providers. But I mean, and some organizations also use dynamic on-demand clusters. But with multi-cluster deployment comes the challenges of inconsistent workloads, policies are not in place, there's a Kubernetes sprawl, there's non-compliance that comes as a risk, managing becomes difficult, and basically things are everywhere. And that is where, I think 5-6 years ago, when cluster API came into place, or Terraform was seen as a, as a manager to all these infrastructures, multi-cluster platform engineering started getting popular. I mean, the first thing is, you can't ignore this. Don't just, let things become complex. But what are your options? I mean, as I spoke about, do nothing, let your DevOps, developer teams manage all of this, infra and ops costs keep growing, and you just don't invest in the idea of it. The second thing is, do it yourself. Cluster API in place, have a state manager, have integrate Grafana, Prometheus, Drone or Jenkins, integrate multiple tools, maybe cluster API as your cluster manager. There could be a, let's say, a cube cost for your costing. So, using a lot of solutions. Then there are proprietary solutions in place, your vendors, Rancher, and other solutions, which can basically be a licensed model, limited in nature, inflexible, hard to extend to maybe different cloud solutions. And then focus on, say, an open source driven solution. Now, when I talk about DIY, you could have built it yourself. But if you talk about what's there in the community, that is where perhaps the idea came up, and where we were building K0s for simpler Kubernetes distribution came in Cordant, because the biggest burden was inconsistent cluster provisioning across different clouds, AWS, Azure, GCP, OpenStack, VMs, bare metals, with its own APIs, tools, fragmented workflows. So the idea was to introduce Cordant, a distributed container manager, or basically a super control plane, to ensure that you're managing your use case specific IDPs in a Kubernetes native way. It has a cluster manager, which helps you provision the life cycles of your different clusters, a state manager to provision the life cycle of your different services, FinOps to manage your cloud costs, and obviously observability to ensure that you are able to monitor and ensure that your systems are behaving in a certain way. You are able to bring in your metrics, logs, traces, and ensure that you are using your infrastructures, your platforms by, I mean, you're using Cordant to manage your infrastructures and platforms in a Kubernetes native open source way. And Cordant is designed to be a super control plane that manages all your other Kubernetes control planes. So basically, Cordant, when you're using your cluster manager, hosts a mothership cluster, and all your other services, your platforms, are basically your child clusters. So it is specifically built for teams, organizations that are using multiple thousand Kubernetes clusters across different environments, and you are able to manage your clusters consistently. You are able to deploy them and update them across a large cluster fleet. You are able to control your costs, and you are obviously able to ensure your systems are secure and compliant in nature. And the key design principles obviously are it's completely open source. All the tools used underneath are open source. It is using a templated approach, so it can be a bring your own template approach. You can write your own template if you have to integrate a particular tool. The automation, the operations are automated, and obviously there's a unified management using your super control plane or the coordinate mothership cluster. And this is how I believe Kubernetes has evolved. I mean, we spoke about how cloud evolved, the idea of cloud, Kubernetes as an orchestrator, how you, and I believe everyone knows how Kubernetes has evolved with, the start of Kubernetes around 10, 11 years ago. We celebrated 10 years last year. They were early adopters. Then a lot of Kubernetes providers, packaged for enterprises, OpenShift, so many things coming in. And then Kubernetes became lightweight in nature. K3s came as a solution. A lot of providers came in with lightweight Kube API, Kube ADM focused Kubernetes. And then the last generation, I mean K0s, I believe, has also standardized a lot of this approach, made Kubernetes easier for the community. And I believe Cordant takes this forward by becoming that orchestrating layer for all your major workloads. And as a recap, what Cordant is, it's a declarative composable platform for managing all your different Kubernetes clusters. With Cordant, you can deploy and manage multiple clusters using a single declarative framework. And obviously, you can, if you imagine you're part of a platform team and your organization is growing rapidly and different teams are deploying applications or on Kubernetes. But where does the challenge start? Developers need self-service access to clusters. They wait for infrastructure team, security and compliance requirements, inconsistent clusters. Operation teams struggle to manage multiple Kubernetes environments. And that is where your team needs a centralized approach. And that is where Cordant comes in. Let's look at the Cordant architecture. Right? It's a like a very simple architecture. There's your KCM controller, which is your Cordon Cluster Manager, which is used for Cordon cluster provisioning. It is using Cluster API under the hood. It is also using Cosmotron under the hood, which helps you manage your hosted control planes, and it is using a CapEx controller, which can help you manage your control planes, say host on Azure, hosted on Azure, AWS, VMware, bare metal, anywhere. There's a Swelltoss controller. Folks who don't know what Swelltoss is, Swelltoss is a project which is basically used to manage the state of your system, the services, let's say, with alongside a Kubernetes service, you're using other services. There's an Nginx controller, there's a MongoDB, other services. So with Swelltoss, you can provision them. And then obviously there's a FinOps and observability side where you are pulling in these metrics. There's already a template of Victoria metrics or Grafana, Prometheus, which can help you pull in. And for your cloud cost management or managing the overall infrastructure cost, we have integrated OpenCost, again, an open source solution. I'll show you the open source testing suites. But this is what the Cordant architecture is doing. And if you have to look a closer overview, this is how the Cordant architecture looks like without all the subcomponents. Your KCM, it's helping you manage your cluster, different clusters. KSM is the state manager. KOF is the observability and FinOps component, which is based on OpenTel, OpenCost, Grafana, Victoria metrics, and more. And you can manage your hybrid cloud, multi-cloud, and different cloud environments and platforms using Cordant. So these are the open source components I spoke of. I think for the state management, we are also using Flux for the GitOps side of things. The cluster manager is built on K0s, Cosmotron, Cluster API, and the other cluster API or the Kappa, KABZ providers to manage your clusters. And it's completely open source. So the components in itself are open source for the community. And this is the architectural overview. I think I already gave an architectural overview, and we have spoken about how the architecture looks like, what is the life cycle, and what exactly are the subcomponents responsible for. In the interest of time, I will not go for a demo, but I will show you a predefined service template and how does it look like and how you can implement it as well. So the Coordinate predefined service templates is contributed by the community, and it is a set of predefined service templates. I mean, if you're trying to use Coordinate alongside other tools, say you want to use a wall key operator, you want to manage your CNI, you are trying to use Cilium, Calico, or you want to use Redis, you want to use different services alongside your infrastructure. So Coordinate basically brings a set of predefined service templates for your different beachhead services, like your certificate management, your ingress controllers, security. And this is what we have integrated as of now, and it is available on the Coordinate catalog, which I believe is a marketplace for templates. So there's Cert Manager, Velero, Istio, FluxCD, Nginx, Kyverno, Prometheus. And platform teams can use these templates directly in their cluster deployment or multi-cluster service to consistently install or use these different beachhead services across their clusters. So the Coordinate templates are streamlining the process of setting up different essential infrastructure components so that you are able to deliver your applications faster and provide value to the users. And this is what one template looks like for the cluster template. As you can see, there's an API version, what is the kind, it's the cluster template, there's some metadata spec, you're configuring it according to the version, and then there's your infrastructure and cluster configuration according to your version, your network, and region. So the cluster template acts as a definition that ensures consistent cluster deployments across your infrastructure. And similarly, you have templates for your state manager. You can deploy it using Helm or Kubernetes manifests, and you have templates for your observability and FinOps as well, where you can manage your metrics, logging, cost management, and visualization. So that is also in form of templates. So that is where we have thought of a templated approach, which supports the community and helps in making it reusable in nature. You can write your own templates, and it becomes pretty easy for the community to bring in more beachhead services for their infrastructures. Why open source? I think it's a pretty simple concept. The idea of open source, I mean, obviously, you as a community, you come back, you contribute to the project. It's from a long-term standpoint, it's sustainable. There's more infrastructure control and flexibility that folks have, and obviously, in a collaborative and community journey, people are able to contribute and ensure that things are simpler, and there is a governance in place, and you are able to create a platform which is not specific to an enterprise or vendor, but which is specific to the larger community. So I believe with this, I will take a pause. I have some other slides, but let's see what we will cover. I think why Coordinate we have covered. Traditional Kubernetes is inconsistent. Manual intervention is required to enforce policies and operational bottlenecks. Obviously, you're scaling your infrastructure. This is just a quick recap of what we have spoken about. With Coordinate, obviously, you are able to ensure that you're just solving the challenges. The cluster management is declarative in nature. It's supporting multi-cloud and hybrid clouds. There's automated reconciliation, that is Coordinate is helping you continuously monitor and correct drifts across the desired state. And obviously, you are able to enforce your policies. You can integrate it with Kyverno or OPA. and you are able to do a lot of other things which are community centric and running your beachhead services. So with this, I stopped sharing my screen. I think we have spoken a lot about it. I will just share the last three QRs for the community. I think we have spoken a lot about what Cordant is, what platform engineering is, what it is trying to drive. But let's just talk about the last couple of slides. So let me quickly share my screen.
Meanwhile, I think we have some couple of questions as well. Folks, keep them in the comments, and after a while, at the end of the session, we'll take care of those.
Sure, Animesh. So the idea here is to streamline the creation and maintenance of IDPs. I think we spoke a lot about IDPs, and this is how an example of an IDP looks like to me as a community member. I mean, you have your different cloud environments, you have your different Kubernetes cluster components and infrastructure management components. You have your cost and your observability in place. There are different services, as I spoke about beachhead services. There's your developer portal. You have to integrate it with your CI/CD, and then obviously your complex workloads, which I believe are now shifting towards a GPU centric or an edge centric environment, and then obviously integrating it with your HPCs or data cleansing pipelines. And that is where Quadrant is coming in as a complete open source native community centric solution, which is helping you manage all these solutions and helping you create and maintain the right IDP according to your use case. This is an example of how things look like. While building an IDP, you can add Backstage as your developer portal. But yeah, this is me wrapping up what we have spoken about. Platform engineering obviously is essential. You need a standardized approach. Democracy is important. Your teams need to work as a centralized team which is distributed, with things have to be collaborative in nature, and obviously you need to try to use the right tools. I mean, beyond Cordant, I feel again it's a new community tool. There are other tools which are not like Cordant, but you can bring it together to build the right IDP, to build the right platform engineering practice. So I believe that this can be essential moving ahead. A lot of folks believe platform engineering might be a concept that has been spoken about for a very long time, but I feel that again we were packaging it as developer experience, developer self-service, enhancing DevOps, a lot of things. But I believe when this concept is becoming popular today, it becomes essential for teams to standardize and ensure that the right platforms are built to make things simpler. So this is where you can find Cordant. Scan this QR and obviously support the project. Check out what's happening in the project. There are different subcomponents: the KCM subcomponent, KOF subcomponent, the Cordant docs. A lot of things that you can learn. And this there you can join the Cordant community. It's in the CNCF Slack. We hosted our first community call 2 days ago. So there's a lot of community interest, a lot of folks who have already started using. We are hopeful that we can uh, build more robust things around this project, more templates in itself. And then you can just check out a training, which I believe folks who have built Cordant have created. So if you want to check out a training and start running Cordant, you can do that as well. So thank you so much, everyone. I really appreciate you sticking around, asking a couple of questions. And again, thanks a lot, Animesh, for doing this, and appreciate it.
Thank you, Prithvi, for joining in. It was quite insightful session. Know more about what Quadrant is doing, what Mirantis is doing, how they are simplifying the platform engineering for developers. And again, just writing the code is a big mess for developers. And then asking them or assuming that they'll also work on workflows, DevOps, or even the unit test is just a hassle for them. So I appreciate what Mirantis is trying to do. We have a couple of questions. Do you mind if we take them?
For sure. I think I can see a question from David Bree and Ayush Dikshit, if I'm not wrong.
Yes, I think we have
So
answered. Is there any resources to start with? Um, we can take the first one.
I think I spoke about it already. Yes, Coordinate supports GitOps and declarative config management. You're already, it has Flux under the layer. So it's obviously supporting your CI/CD or your GitOps pipelines in itself, and it is declarative in nature. I think I spoke about it at large with the templated approach and all the integrations that you're able to do and run your beachhead services. So yes, it supports GitOps and declarative config management. Uh, I think I am not able to understand Mirantis mean by. I think it's in the context of Coordinate in itself, unique underlying implementation. So there are two meanings to it. One of them is obviously the tools that are packaged under the hood for Coordinate, where you are using the power of cluster API, Swelltos, OpenCost, Victoria Metrics, Grafana. You are also using K0s and Cosmotron. So when the K0s family started, the idea was to make Kubernetes deployments simpler. But with Coordinate, the idea is to make Kubernetes, not just Kubernetes, but infrastructure deployments simpler. So that is where the concept of unique underlying implementations come into place. And the second one is obviously how you can use Coordinate or implement Coordinate by using it as a super control plane, and using Coordinate under the hood of all the infrastructures and clouds and clusters that you are trying to drive. So I believe that's the context, but if I'm missing out on something, I'll go through it again and maybe drop a comment. And yes, I shared the resources. So one more thing, maybe I'll drop it in the comments section. That is, we have started off with the Coordinate tutorials. So we are trying to share some aspects of Coordinate, what exactly is coming up in the new tool, or new releases. So stay tuned for some of it. Join the community. Maybe you can ask your questions. The docs are pretty helpful. So I'll just drop a couple of things in chat. One of them is the tutorials, and the other one is okay. It's asking me to connect to
I
YouTube.
think
Maybe
you can share it with me, and I'll drop
yes,
with other
Animesh.
resources.
You
Yes,
can perhaps share it with the folks. But yeah,
awesome, awesome. So, folks, if you have any more questions, feel free to drop into the comments. And thank you, Prithvi, for taking out time on the Saturday, especially.
no
Um,
worries, no
Hope you
worries.
enjoyed the session as well as we did. And let's move on.
Thank you so much, Animation. Thanks so much, everyone, for joining in. I appreciate it.
Awesome. Next, we have Ram. So let me tell you more about Ram. Ram is a chief evangelist at Cloud Foundry Foundation. He's an engineer by practice and educator at heart. He was plunged into technology evangelism along with his journey as a developer and hasn't looked back since. He enjoys helping engineering team around the world and discover new and creative ways to work. So let's get started with Ram. So we have a recording. Of the RAM session. He's here. He'll take on the Q&As. So feel free to drop in whatever you have, and hopefully we can take those questions in parallel. So over to.
Welcome to my talk. Welcome to the Cloud Native CNCF, CNCG, Noida folks. Thank you for having me today, and thank you all of you for being on the stream. My name is Ram. I work as an open source evangelist at the Linux Foundation. My primary focus is on the Cloud Foundry project, which is half cloud native, a lot of Kubernetes, but also like has a decade long history of working with cloud infrastructure and on VMs and making the developer experience and the whole platform engineering experience a reality for many teams in the world. So today's talk is somewhat special. Not because I'm giving a recorded talk after a long time, but more because I aim to present like a whole taxonomy of things. I do have a bunch of demos and things that I'd like to show, but in the interest of time, I don't know how much I'm going to be able to show versus how much I'm going to talk to you about things. Now, my goal today is to talk about the breadth of how you can do platforms on Kubernetes. There's not one, there's not two, it's probably like a dozen ways in which you can architect a platform over Kubernetes. But all of that confusion is not what we'll talk about today. Well, we'll talk maybe about like half of that confusion, but the idea is to present what Kubernetes is, what it is capable of, and showcase really some of the things that are possible with Kubernetes and how you can figure out your own path amongst all of the tons and tons of different things that exist in the Kubernetes world. Again, like I said, there's a lot for me to speak about and show. So if I'm not able to do like a demo component of the whole thing, just don't hold it against me. I do come prepared, but it might not be possible given the paucity of time and the format. One other thing, if you have any questions or comments or thoughts as you watch this, you can type that out in whatever chat stuff there is, and I'll try to answer questions as best as I can while the stream is going on. Not a problem. So don't feel shy, don't feel inhibited because this is like a virtual platform and things like that. Speakers before me did great. Keep the enthusiasm up. I know this is the last stream. After this, you're going to go off to a wonderful lunch on Saturday. But for the next 20 minutes or so, let's focus on platforms and Kubernetes and the whole story there. Now I'm switching to presentation mode. The story really begins when Kubernetes started to become mainstream and become adopted in enterprises, in startups, in small ways, in big ways, across the organization, etc. Kubernetes really reformed the way we thought about containers. And if you think about Kubernetes, it was mainly designed to solve two things. One, keep restarting my containers when they fail. Not if they fail, when they fail, because for sure underload containers are going to break, and that was an eventuality. And a lot of teams pre-Kubernetes were sort of struggling with how to keep their applications and containers constantly running, and how to basically quote unquote restart them once they fail. And Kubernetes did a wonderful job of this. The second thing that Kubernetes did extremely well was what is known as bin packing. So putting the maximum number of containers possible within a given compute. So you take compute or virtual machines and you slap a Kubernetes on top of it. That's how it works. And Kubernetes then becomes the abstraction you use to interact with the compute that you had. So depending on how much compute Kubernetes had, it was able to figure out how many containers to pack into this and how best to keep these containers running. So it was built to solve a very simple, very specific problem. But then, like so many other things, the world around Kubernetes really switched, and a lot of people started to assume that because Kubernetes was this abstraction on top of compute or virtual machines, people just thought that this is a platform by itself and it has to give me answers to observability, it had to give me answers to monitoring, and it had to give me answers to some security stuff that I had. It had to figure out some kind of things having to do with databases and other services that I wanted to consume. And so human beings, as we are, we tend to skew definitions a little bit and confuse ourselves with what a tool is meant for and how we use it. So a lot of times, you'll put your pen in your ears and do that. So a pen was never meant for that. It spoils both the pen and your ear. So that was never the intended use of a pen. Much like that, Kubernetes was never meant to be a platform in the traditional sense of a PaaS. It was just meant to be an abstraction that managed containers very well on any given compute. So this tweet about from Kelsey Hightower about platforms and Kubernetes not being platforms and us not confusing Kubernetes, which is an abstraction for better container management, with platforms that could be answers to everything. So this is about 7.5 years old or something like that. So things should have improved by now, but not. Yeah, I mean, yes and no. There's obviously a lot of time and effort that teams have invested into platforms, but also we still don't have a clear definition about what is what and how best to use Kubernetes versus how best to design for platforms and things like that. So like I said, the goal of this session is to clarify all the options available so you can make an informed decision about what platforms to choose or what to base your Kubernetes platform strategy on. So this is a screenshot of the landscape. So since Kubernetes was launched many years ago, it has really exploded in terms of the number of projects and the sheer volume of projects where you probably need everything from each category, but you probably don't need all of these. A lot of them do similar or complementary things. The problem is not a lot of people are immediately aware of what to pick, what to leave, what they need, etc. And this kind of overwhelms a lot of teams, and they don't really have a good idea of, okay, let me do this combination of projects from the CNCF for my platform versus why should I advocate one versus the other, etc. So it's become a big complication that, like I said, overwhelms users. But that can be both a bit of a good thing and a bit of a tricky thing, because you want people to pick and choose what they'll use, and you have tools that are optimized for very specific needs. But B, you don't want people to pick and choose, because then they really go out and make it a wild ride, not knowing what exactly to pick and leave. So it's both an advantage and a disadvantage being so popular and being witness to such an explosion of tools. But that's the reality that we have to contend with, and from here we need to build strategies that people can use. So given this complicated and overwhelming landscape, where do we begin and how do we proceed? That's the big question that we need to ask ourselves. But whenever I think of Noida, what I can think of is a lot of construction. I see trains and railways being built. I see a lot of houses being built all the time. And I see that you're getting another airport as well. So I've lost count of how many airports there are around Delhi. But everywhere I see in Noida, there seems to be some kind of construction going on. I think that has a nice analogy for us, which is during construction, you can make use of cement in its raw sack form. And raw in the sense, you bring a sack of concrete or cement and then you tear it up and then you mix it up with sufficient amount of water and sand, and then it becomes usable, and then you can build whatever you want. You can probably do roads, you can do walls, you can do rooms, you can do roofs, all of that. There's also another way in which people build things, which is they do something known as a precast. So instead of mixing the cement and the concrete or whatever it is by yourself, you get these blocks and then you assemble these blocks, and then your construction moves at a slightly different pace. It's a different experience, so to say, for the person doing the actual construction. So there's no mixing and stuff. You have these blocks, you have some mortar, and you can go to work with it. And then there's other complicated things that can also be prefabricated and come, made of the same material, mind you. And these come in different shapes, different sizes, meant for different things, etc. And so you can have a lot of things done with the same material, producing the same sort of end result, but the path getting there can be dramatically different. And so that's the story of platforms on Kubernetes as well. There's dramatically different paths depending on what tools you pick from the landscape in order to get to a functional platform that you want to use. Now let's talk about the first and probably one of my favorite tools in the toolbox. And if you can't guess from the logo, and this can be like sort of a quiz, if you know the name of the project based on the logo I show, just type it into chat. You might not get any gift for it, but at least bragging right. So this is the Cloud Native Build Packs project. Build packs aim to provide a build experience. So from the name you can probably guess it's a container build tool. It's an alternative to Docker build. If you use that, I'm sure like a lot of you use Docker build in order to build your container, and build packs offer an alternate in the form of a very similar OCI based container at the end of the build process, but it's exactly the same what you do. So there is what is known as the pack CLI. Pack will allow you to run the pack build command, and then build packs have an architecture of their own where they also compose container images in layers with like a build image for the base, and then they'll include all the layers of the application stack, and then build the final container image using a run image. So it's like an alternative to Docker, but also like multi-stage Docker builds by default. So they're very useful in my opinion. So build packs, what I like about build packs is they have the same homogeneous build experience irrespective of what language or framework you're using. So it doesn't matter you use Java, doesn't matter you use PHP, doesn't matter you use Go, I don't know, whatever other hipster language is popular right now, TypeScript maybe, but who's writing code these days, right? It's all about the vibe, which I have some strong opinions, but this is not the talk to be speaking about those. But cloud native build packs simplify that build experience and give you a better path, in my opinion, towards getting containers built and getting images packaged as containers ready for deployment. They're easier to automate, they're slightly more secure because they're non-root images by default, etc. And they're comparable to any Docker based build that you might use. So that's cloud native build packs. And why I wanted to showcase this first is if you want to cobble together a build and deploy strategy by yourself, then this is a good way to do it. So cloud native build packs will allow you to do the build, and then you can put it on any container registry that you're using, and then further downstream you can use any CI/CD tool that you have in order to do the deployment. So I'd say use Jenkins, but this is the CNCF meetup, so use Argo, I guess. But I'm sure all of you will talk about Argo today, but when you go back to work on Monday, you'll all be using Jenkins. So doesn't matter. Whatever method you want to deploy in, you can still do it when you create a container with cloud native build pack. So whatever is your existing strategy for deployment, you can have that with build packs. The next project I wanted to highlight is Dapper. So Dapper is somewhat of a very popular CNCF project. It's I think it graduated very recently, maybe like a year ago or something like that. What I like about Dapper is how it takes a modular approach. Like there's Dapper building blocks for everything. When you're building or when you're architecting a distributed application, you want event driven architecture, you want message queues to be set up, you want endpoints to be available and APIs to be available, things like that. So Dapper can do all of these things for you, and it does it by using all of these individual modular components that you can combine and put together in order to form your final application and the final architecture. So all of these different Dapper modules you have for communication, for state, for workflows, etc., all of those can come together very nicely. And there's a ton of good documentation that you can use to get started with Dapper. Now, what I like about Dapper is is how all of it is composed as different building blocks or modules that you can make use of. Excuse me. So you can use some stuff for state management, for example. When you're building stateful services, you can have like publish, subscribe, message queues between your different services. You can it simplifies service invocation, it does secrets, it does so many different things, and they've expanded to like AI and agents and all of those things as well. So very popular project, very good way to architect your applications if there was one. And if you're looking to build platforms but you don't want to like write everything from scratch and you want to do like a small abstraction, eliminating a lot of boilerplate, then Dapper is an excellent way to do that, in my opinion. This is probably very easy. It's one of those projects that a lot of people already recognize, already use, and already have it deployed, etc. This is for those who don't know. This is the ice cream logo. Is like, as much as kids love ice cream, the CNCF community loves Crossplane. So I think it's a very appropriate logo, and Crossplane works with basically what are known as custom resource definitions in an extended way or in a composite way. So you use CRDs to denote custom resource definitions in Kubernetes. You use XRDs when it comes to Crossplane, and they basically perform the same or a very similar function. It's just that they're custom to a lot of things, and they do things very specifically. So Crossplane is designed to be able to extend the concepts of Kubernetes and create a lot of endpoints that can easily be connected, and you can consume a lot of the information very easily across these endpoints. So it shares those underpinnings with Kubernetes as such, and they're very popular because they can trigger a lot of things using specific Crossplane XRDs, and so that's what I really love about Crossplane. You can build anything with Crossplane, provided you buy into their notion of how to write an XRD and how to create these abstractions and things like that. And because a lot of us work with distributed services that have a lot of custom APIs and things like that, it's easy to create these endpoints and have them consumed using Crossplane as the control plane for all of your different resources. So I really like how the project really came together, and these composite resource definitions or XRDs are what make Crossplane tick. maybe I can quickly, hopefully people can see this. Um, I'm just going to open up like a cross-plane thing, and this is an example of how you can sort of bring something together using cross-plane. Um, if you look at this demo, um, it'll show you how you can have some configs in a cluster, and how you can create a lot of custom or composite resource definitions in order to manage things like this. Just creates like a namespace, but even that is very useful. So you can create like a YAML that basically says create a namespace on a particular cluster, and you can repeatedly deploy this using crossplane. So sky's the limit, to be honest, when you're working with crossplane. And I really like how they've been able to architect a successful abstraction over Kubernetes and provide all of that. And now we step into these other projects where a lot of teams have attempted to architect a very general purpose internal developer platform, or IDP, which is the darling of the platform engineering world. And they're using these IDPs to really showcase what or how Kubernetes is meant to be or should be used. So it's a very tricky proposition in terms of balancing your opinionated needs of a team with all of this openness that exists in the CNCF ecosystem. And so a lot of the people in the community came together and started to define concepts and started to define some fundamental things about what an application should look like, what a framework should look like, what a platform should look like, and how do you deploy these applications and things like that. So one such effort is the Kano effort. Kano stands for, take a guess, Cloud Native Operational Excellence. So quite aspirational, but also like quite a mouthful. And there's a lot of information that the Kano community has put out about what an IDP architecture or an internal developer platform should look like and why it should be that way. And so they aim to get your platform teams to build IDPs faster, more reliable, in a more secure, and all of these ways. So they're all built on like cloud native principles, obviously. Otherwise we wouldn't be discussing them today. But they're all built on these foundational aspects that are open and like Kubernetes and all of these things. And they allow people to sort of modularly pick and choose what they want to install on their IDPs, and they'll give you an IDP blueprint based on that. And then there's another project that does something similar, and this was the one that I came across first, even before Kano. And this one is called Porter. Porter is meant to design how you want your application, the stuff that you need to deploy it. The stuff that you need to deploy can be something as simple as some config files, something as important as secrets. Maybe you need some bash scripts here and there in order for a deployment to come together. And the idea behind Porter was to package all of these together and keep all of this operational knowledge preserved and available for anybody that's trying to do a deployment, and they don't have to check in like 15 different places about where to find this information, etc. So that was the motivation behind Porter. Now, ever since Porter started, a lot of it has also grown and applied to areas other than just the CNCF. So Porter has really expanded its reach, and it can be applied to a lot of places that are not just relegated to the CNCF project. This logo has its name. This is the Radius project, and the next 2 or 3 projects that are going to come are slightly more concrete implementations as opposed to abstract concepts like Kano and things like that. So Radius is a tool that has its roots in Microsoft, and Radius provides for these abstractions known as recipes and biceps and things like that, which basically allow you to define how you want your application and services and all of these architected. Radius is currently enjoying sandbox status, if I'm not wrong. It's a good abstraction and it defines a few things, but there are some challenges I've had in getting this to work. So this is not on like the top of the list of the platform projects that I would recommend you take a look at, which is not the case for this one. If you can guess from the logo, this is KubeVela. KubeVela is a project that defines how applications and all of these artifacts should look like based on something they call the open application model. Now, the OAM or open application model for KubeVela dictates how you want an application designed and defined in order for you to be able to deploy it and maintain it better. So they advocate designing applications in a particular way and things like that, and maybe there's some things to show here. Yeah, so if you look at this YAML, which I guess we all love to do, otherwise we wouldn't be sitting here on a Sunday afternoon talking about cloud native. So they define a lot of primitives. So they have something known as components, they have something known as policies, they have something known as workflows, and so you define your applications in terms of all of these things, and then KubeVela can stand up all of them on your Kubernetes cluster for you. So if you want a database, if you want a messaging queue, if you want an application with like so many replicas, etc., you can ask for all of these, and you'll notice that they come with a lot of these names called traits and components and what have you. So all of these are KubeVela primitives that they use in order to define an application, and then they'll deploy the application based on what their understanding of the application model is and how they want it architected. There's also a project called Corifi, and that belongs to the Cloud Foundry Foundation. So not truly CNCF, but like open source and belongs to the Linux Foundation. And Corifi brought a lot of knowledge from the Cloud Foundry world, which was like a huge PaaS product existed before Kubernetes, continues to operate in a lot of big enterprises even now, and they really perfected this developer experience, operator experience, and all of these things. And so they brought a lot of those lessons to be an abstraction over Kubernetes for a lot of the app developers and the operators to really simplify their workload. So again, very useful project if you want to consume a platform all by yourself. And Corifi, and like there's a thing called 12 factor which was pioneered by the community at Heroku, and they advocate for applications being designed in a certain way, and Corifi follows that philosophy a lot. So designing applications the 12 factor way, deploying it in the open application model way, those are all very complementary, but the ideas about how your application should be, how your services should attach, etc., they all come from this old manifesto called the 12 factor app, or an architecture pattern for applications themselves. So yeah, I think that's a lot of information and a lot of projects. I really have to stop now before I overwhelm you. In summary, Kubernetes is amazing. A lot of people can definitely benefit from it, but you might not be able to extract benefits right away. You need a platform strategy around Kubernetes and how best you can use it for your developers. You can cobble something together using build packs, which is, in my opinion, one of the best ways to build and automate container creation. You can instead use Dapper for a lot of the services and the distributed systems that you want to design. You could also use crossplane to get to the same end, like I said, but in a different way. Or there's projects like Radius and Corifi and Kubevela that really give you this. Once you've built it the way you want to, you can then use these projects for deployments and maintaining stuff in production. Obviously the future is AI. It's going to eat up all of this. Once you let agents run the production infrastructure, then you don't have to worry about anything. But in my opinion, that's how the apocalypse starts. But I think this was a fabulous session overall. Thank you so much for having me. I really enjoyed preparing and presenting this talk. This is me on all kinds of social media, so feel free to find me, tag me, say whatever it is that's on your mind, etc. I'm happy to hang back, answer some questions, etc. But thanks for joining, and to stay in touch. Bye bye.
So that was an amazing talk, Ram. I think we have few questions which you have answered. We'll just take one. Can you support Avya, assuming this was when we started talking about um, Porter or Crossplane?
Yeah, I'm not sure that question is relevant. Um,
Um, yeah, I think we have mostly, and you have already answered them in the chat. I think I'll share the reference links
yep.
uh, after the session ends. And it was great having you, Ram. I know you're traveling, and I hope you had a
No,
great
thanks for
time
accommodating.
talking about ending. Yeah, cool. Thank you all. Thank you for joining in. And we had one more thing to discuss before we go. So we had a giveaway that was going on, and its winner is Amrish Kumar Sharma. And if you are in the stream, do ping us at LinkedIn. I will reach out to you. So you can collect your swags from us at the CNC CTNF party that's happening on August 23rd in Noida. Thank you, everyone. Thank you all for joining in on the Saturday. I hope you have a great weekend ahead. Thank you, everyone.